5.3, we will continue to write linear equations. This time with the information that we're given is going to be 2 points. So if we have 2 points, we know that we can find the slope because we can find the difference between the y's and the difference between the x's to find the slope. And then we will continue with what we were doing in 5.2 to find the y-intercept. So the first thing we're going to do in example 1 is to find the slope of that line. So I'm going to go ahead and find the difference between the y's and the difference between the x's. So I'm going to go ahead and I'm going to do -4 minus 6, and that's going to be over 3 minus 1. And if I have a -4 and -6, I'm going to have -2, 3, I'm sorry, -10. 3 minus 1 is 2. And so my slope is going to be m equals -5. Now with my slope, and now I have 2 points that I can choose from, I'm going to use the 0.16 because they're both positives. So I'm going to go ahead and substitute that in. I'm going to use this point for my x and my y. So y is 6 equals, I'm putting it in slope-intercept form, my y equals mx plus b form. So 6 equals my m, which is 5, my x for this point is 1, plus b. So now I can simplify. -5 times 1 is -5, so I'm going to add 5 to both sides. And I come up with b equals 11. So if I go to write my equation now, I have a slope and a y-intercept, and I can write my equation. My equation is going to be y equals, and it will be -5. I'm not going to have enough room there. Let's go ahead and get rid of that. Let's see if we can fit it in now. Whoops. Y equals -5x plus b. And b was a positive 11. So if I go ahead and I reveal my graph, if I was to graph this, if you were to graph this, you would go ahead and you would plot your 11, 0 first for your y-intercept. Then you would go ahead, or 0, 11, sorry, for your y-intercept. Then you would apply your slope, -5, 1, so you would go down. Your rise would be going down 5, and you would run 1, so that's where you're getting the 0.16. So this would be your B. It'll let me write on there. This will be your B. This is your applied M. And then if you could even check by going back to one of your points. We'll go to this other point that we didn't use. 3, -4, and when we drew our line in, we can see that the line goes through that exact point. So this slide will just show you the steps that you are going to go through. First, you'll find your slope. Then you'll do like you were doing in 5.2 and find your y-intercept. Then you'll write the equation of the line, and you could graph it and see if that is correct. Now we're going to talk about perpendicular lines. We mentioned this when we were talking about our parallel lines, that perpendicular lines would not have the same slope. We're going to look at the graph here on the coordinate plane with a couple of the coordinate points labeled, and we can see this line segment AB, and that segment is perpendicular. And perpendicular means that it makes right angles. So that line is perpendicular, that line segment BC is perpendicular to AB. So we can apply the same kind of or similar rule as we did with our knowing that our slopes were the same in parallel lines to find out perpendicular lines. So if we were looking at the slope of AB, we would go ahead and we would find that slope as, let's do it as negative, oh, let's do 1. We'll do this as our second point. So we'll do 1 minus a negative 3. And then in that same order, the next point would be negative 6. And then that's the difference with negative 4. So the slope of AB is going to be 1 minus a negative 3, so that would be add the opposite, so that's 4. And 6 minus a negative 4, again, add the opposite, so we would get negative 2. So the slope of AB is going to be negative 2. Now, if we figure the slope of BC, let's go ahead and we'll start with over here for our second one. So we'll do 0 minus, again, I'll do my negative 3, and we'll do 2 minus, and again, it's going to be the negative 4. 0 minus negative 3 would be a positive 3, and 2 minus negative 4 would be a positive 6. And so I can go ahead and reduce that, and I get the slope of 1/2. So that's the slope of BC. Now we started out saying that those lines were going to be perpendicular. So if you study the slopes of both of those, you're going to see that they are reciprocals and that they are also opposite. Okay, negative 2, its reciprocal would be negative 1/2, but we're going to do the opposite. So it's a positive 1/2. And that's true for all perpendicular lines. If they're perpendicular, their slopes are going to be the opposite reciprocal. Moving on with that, now we need to find the y-intercepts. So let me see if I have that on the next page. I do not, so I'm going to give myself a blank page. Let me copy this real quick so that we can refer to this. Go ahead and get rid of my markings. It's making it kind of hard to see those points. And then I need to unlock. And I'm going to copy that and put it on a new page. And lock it back up. Okay, so we know that our slopes, I'm going to go ahead and write our slopes that we figured from the other page. So AB's slope is going to be that M was equal to a negative 2. And BC's slope was going to be that the opposite, so it's a positive, and the reciprocal 1/2. Now we need to find our y-intercepts. So I'm going to go ahead and I'm going to substitute what I know in for line AB. So we'll do the line segment AB first. So I'm going to use my let's use, to stay with the way they have it in the textbook in case you're looking in there, we're going to use the points here on B. So I'm going to say my y would be negative 3. That didn't make it any better there. Go back and try it again. Negative 3 equals, my slope we figured out was a negative 2. My x in this case is a negative 4. And this is going to be plus b. So I have negative 3 equals, simplifying, negative 2 times negative 4, positive 8 plus b. Subtract 8 from both sides. And I'm going to get that b equals negative 11. Now if I do that on the with line segment BC, I'll do it again the same as they have it in the book. So we're going to go ahead and we're going to use the same coordinate point there. And I'm going to say that the y would be -3 again, equals my slope is a 1/2. My x term is 4, sorry, -4, see if I can work that in there. -4 plus b. Let's go ahead and simplify. -3 equals half of -4 is -2 plus b. Add 2 to both sides. And I get -1 equals b. Now you're noticing that because they are perpendicular, it's going to follow the same kind of rule as our parallel lines. They're going to need a different y-intercept. They can't cross the y-axis at the same point. So I don't know if I can fit this in here. We're going to try. So if I go ahead and write the equation for AB, I'm going to get y equals -2x minus 11. And the equation for the segment BC would be y equals, and that was a 1/2 x, and that's -1. So those would be the two equations that we can find of the perpendicular lines just from the two of their points. Our last example is going to be the real life situation. And we're going to look at an archaeological dig. So we noticed that person 1 found a 40 centimeter femur and it was 162 centimeters in height. The next one was 45 centimeters and 173 centimeters in height. We're going to change those into coordinate points. So my first coordinate point would be 40, 162. Again, think about if you were going to graph this. The x coordinate or the x axis would be the femur length, and the y axis could be the height. So that helps you with picturing your x and y points. And now I have 45 and 173. So now I have two coordinate points. I can go ahead and I can follow the same thing that I have been doing. I would find the slope first using those two coordinate points, and I'm going to go ahead and shorten this up and tell you that it turns out to be 11/5, and I could also say that that could be 2.2. Now the reason I'm doing that is just because we are graphing, and sometimes it's easier to see it graphing. My y-intercept is going to be that b equals, so I'd be substituting that back in one of the points, and I'd get that b equals 74. And so then if I look at a graph of that equation, I have y equals 2.2x plus 74. So if I look at plugging new ones in, so the 43 centimeters is their next one. So when I go from 43 on the graph, I plug it into our equation, and I end up finding this point right here, 169. So I skipped some of the points of the calculating because that was in example 1 and 2, and basically just showed you how you could take real life information and end up getting coordinate points and following that same procedure, and how that would then show up on the graph if it was a graph of a linear equation. And that finishes off 5.3.